How you doing, folks? I'd like to welcome you to Math with Kieno. I got an email, and it was pretty interesting. The email I got today. It's just nice to see that people are kind of watching my videos, and they're learning, they're growing, and stuff like that. One thing I found out is that there are parents that they'll watch my videos on say like fractions or I don't know math or whatever I've done videos on, and their sons and daughters, they'll have like problems like, well, mom, how do I do this? Or dad, how do I do this? And what I've been finding out is the parents have actually been looking at the videos and then okay, well, son, this is how you do it, or daughter, this is how you work out this math problem. And it's pretty cool, and I encourage that. Learn with your children. If you haven't looked at algebra in a long time, or fractions or whatever, functions, whatever, your kid's going through it, relearn it, refamiliarize yourself with it, so you can help them with their homework and things of that nature and stuff. It's kind of cool. I mean, well, guys like me, I like math, but not to go off tangent here, but my point was, it was pretty cool. I got a pretty cool email, and I'm going to read it. I very rarely kind of put my face on my videos unless I'm doing something, but it's pretty cool. I just wanted to read this for my viewers, listeners, whatever. But it's kind of cute. It says, "Dear Math with Kieno, I'm not sure if I should call you Mr. Kieno, Mr. Thomas, or Mr. Math with Kieno. My mom has been watching your videos for a long time and helping me with my homework. I'm taking algebra now, and she works a lot and has not had time to keep up with your videos. Could you please do a video on solving basic equations and give me some examples for solving word problems? Thanks." And this comes from Rosie K in Lake Station, Indiana. So that's all. I thought that was kind of cute, and I'm going to go to the board where we get stuff done. This is where all the magic happens, on this little board. So Math with Kieno, solving equations, basic level, and then we're going to throw in a little bonus. Actually, because some people have problems with word problems, converting the words into the mathematical format. So we're going to work with that. For solving basic level equations, what we have is we have some known information, and then we have some unknown information. So there is two types of info. We have some known information and some unknown information, and we have to take what we know and find out what this unknown information is. Now, I know that sounds a little cryptic or whatever, and I think we're even a little tilted here. And I'm wondering, how can we get that out of there? I think that does it. We need to tilt down a little bit. There we go. I think we might have something there. Okay. There we go. I think we got it there. So, let's see. Alright. So, again, we're looking for our unknown based on the unknown. We're looking for the unknown based on the known information we have. Okay, that made sense. Sorry, Rosie. I'm going to get it done. So, let's say we had the letter A minus 1 equals 7. Okay, so our known information is something, we don't know what this is, minus 1 equals 7. I already know it's 8. Because I know if we're going to get 7 as a result just based on subtracting something, subtracting 1 from something, it can only be 8. So, let's look at how we do it. We have our known, unknown information and our known information, but don't let that scare you. Okay, when we look at this, I look at it like this. We have our unknown, and what we need to do is we have our equal sign here. We get all our known information on one side and our unknown information on another side of the equal sign here. So this equal sign is very important. Very important. It's kind of like our balance on a seesaw or something. Okay, so this is our seesaw up here. We want all our known stuff on one side. We want all our unknown stuff on the other side. And I would prefer to have my unknown information on this side, to the left of the equal sign, known information. So what we have to do is we get to look at, basically what we're doing is, and I want to keep this theoretically the right way, we'll take A minus 1 and then plus 1 equals 7 plus 1. Okay, so you see what we did here? We had A minus 1, but in order to cancel out that negative 1, we have to add a 1. Okay, so whatever we do on this side of the equal sign, we have to do to this side of the equal sign. So we added 1 here, and we added 1 there. Okay. The A minus 1 was already there, but since minus 1 plus 1, they cancel each other out. It's a 0, basically. It zeros each other out, and then we wind up with A equals 7 plus 1. A is equal to 8. And if we go back to our original, we take the 8 and input it here, and then we get 8 minus 1 equals 7. Okay. So that's the theoretical way of working this out. Let's take another one. B plus 2 equals 12. Now, I'll go up higher and just see what we would do. We would say B plus 2 minus 2 equals 12 minus 2. Or what I would do is, with the rapid method way, just imagine 2 jumping across the equal sign and then changing positions. So it flies over here and then becomes a negative 2. It's not a positive 2 because it floated across the equal sign. So my rapid method would just be B equals 12 minus 2. This 2 just floated over and became negative. And theoretically, that you could go through all this if that helps you sleep at night. But the way I look at it is 2 flies to the other side, becomes negative. And then I'll work out the mathematics. 2 minus 12 is equal to 10. And then we could go back to our original. 10 plus 2 equals 12. When we replace in our original equation, what? The unknown plus 2 equals 12, which was our original question. So I showed you the regular method, and I'm going to go back. I'll do the, let's see here. We got another one here. 2c equals 14. Now in algebra, when we put a number and a variable together, it's just like saying 2 times c equals 14. Okay? Just like saying that. But we understand 2c equals 14. So what we have to do is we have to separate. We got to take this 2 out of here. All right, so how do we take this 2? Remember, whatever we do on one side, we got to do to the other side. So in order to get rid of the 2c, I got to divide 2c by 2 and divide 14, divide that by 2. Okay. And if you go into my fractions video, you understand that every fraction is a division problem. So the 2's cancel out here because 2 divided by 2 is 1, which would theoretically make this 1c, and any variable by itself represents 1 in that letter, which is basically c anyway. And 14 divided by 2 equals 7, so the c is equal to 7. So we can put this in 2 times 7 equals 14. Okay? Not too bad, right? Not too bad. And again, I'll just reiterate, you know, if we see a c there, that equals 1c, theoretically. Okay, the 1 is just understood because 1 times anything will be itself. So 1 times C is going to equal C. No problem. 1 times 2 is going to equal 2. 1 times 3 is going to equal 3. So just a quick review. Uh-oh, dropping my eraser. Okay, so now, again, let's say D plus 4 equals 14. I could do it the old-fashioned way. I could say D plus 4 minus 4 because I got to get rid of this 4 and get everything to the unknown side. And then 14 minus 4. The two 4's cancel each other out and just leaves the D, and then 14 minus 4 is 10. We can go back to our original equation. Insert 10 into the D position. 10 plus 4 equals 14. And that is a true statement, 10 plus 4. Or if we had our number line here, and 1 or 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we're at 10, and we 1, 2, 3, 4, and we add 4 units in the positive direction, 1, 2, 3, 4, we would end up at 14. Okay, no worries. We are getting good at equations. Now again, me, for the rapid method, I just like to think of E minus 2. I just like to think of the 2 jumping over the English equal sign, sorry. And then I don't know why I'm so silly right now. The 2 jumping over the equal sign and changing sign. So E equals 5 plus 2. Right? It jumped over, became positive 2, and then E equals 7. We go to our original equation. Replace 7 with E. 7 minus 2 equals 5. Okay? Now we're going to start flying. Because we're boning you up, getting that mental muscle, that mental muscle built up for testing. F3 equals 12. And again, this means F is the same as F times 3. Now how do we got to get rid of that 3. So what we have to do is divide by 3 on both sides of the equation. These two 3's cancel out. And 12 divided by 3 equals 4, so F is equal to 4. We go to our original equation, replacing 4 with F times 3 equals 12. 4 times 3 is equal to 12. And just for a refresher, if you don't understand when we have two numbers in parentheses side by side to each other, multiplication can look a couple ways. 4 times 3, 4 asterisk 3, 4 with the 3 in the parentheses, 4 in the parentheses with the 3, as long as it's outside, that indicates multiplication, or jamming them together with no symbol in between. Or 4 times 3. So these are the many faces of multiplication. I know that was kind of corny, but it's true. These are the many faces. The many faces. And in every case, they're going to equal 12. Okay? Many faces of multiplication. Well, I got to do a video with that one day. Alright, so moving right along. See what we got. Okay, looking good. Alright, let's do another one. Alright, 10 minus I equals 3. Now, this is a funky one, because in order to truly find I, we don't want negative I, we want to find I. Now, in this situation, this is the only situation in which I would change my thing, because I like my variable to be on this side. So, like, I'll just put variable side, or unknown, the mysterious side of the equal sign. And then this is the known side. Boy, I've come up with all of them. So and when I look at the equal sign, I like all the unknown information to be on this side normally, and all the known information to be on this side. When they pose us with a question where the variable is actually negative, then that's when I just flip it around. I don't like it like that. And anything that jumps on the opposite side of the equal sign, it changes its positive or negative symbol. Okay, so I'm going to do this the traditional way that they like to see it, because they like you to think of adding I to both sides. So it would look like this. It'd say 10 minus I plus I equals 3 plus I. Okay. And then what we could have did too is simultaneously we could have subtracted 3 from both sides. So let's do that, because we gotta get everything on the known side on this side and the unknown side on this side. So it would be 10 minus I plus I minus 3 equals 3 plus 3 minus 3, because we did it on this side of the equal sign. So we got a minus 3 here, and we've also added an I plus I. So what happens here? The negative I and the positive I cancel each other out, and the 3 and negative 3 cancel each other out. So we are left with 10 minus 3, which ultimately means 7, equals I. So then what we do is we have our I on this side, so it's positive. We want to find the positive unknown, not the negative unknown. Now what we could have done, we could have solved this, left it like it was, and then just understood that. But if you're not that good at this stuff, let's just keep it simple and keep the I positive. So then we can go back to our original equation. 10 minus 7, because that's what I equals 3. Let's see if that's true. When we're doing order operations, you have to get rid of the parentheses first. So the negative distributes into the 7. And is 10 minus 7 equals 3? Yes, it is. So that's how we check our work and find our eraser when we drop it, which I have not, but just give me a second. I'll tell you, that little thing bounces all over the place. I'm gonna have to start it. Just give me a second, folks. If we don't find it, no problem. We will just press on here. Oh, there we go. Found it. Okay. So again, and I'll just keep this up here. We like this to be our unknown side, equal sign, and then the known. So this side is so mysterious. Okay, let's say, I minus 8 equals 7. I minus 8 equals 7. We'll send the 8 to that side. I, boom, plus 8 equals 7 plus 8, which equals 15. We'll go back to our original. We'll plug in I. 15, where I is, equals 7. Is that not true? 15 minus 8 equals 7. I like doing these. 2k equals 8. Now this essentially is a problem where we need to get rid of the 2, so we will divide both sides of the equation, balance point, or what we call an equal sign, by 2. So what I'll do is I'll make a little fraction here and a little fraction here. Okay, so the 2's are going to cancel out, and 8 divided by 2 equals 4, so k is equal to 4. We plug in 4 into our equation. 2 times 4 is equal to 8. And that is true, ladies and gentlemen. So these aren't too bad. These are not too bad. Where we at? Okay, and we'll do 6u is equal to 24. We have to divide both sides by 6. Line here, line here. We're dividing both sides by 6. The 2 6's cancel out. 24 divided by 6 is 4. U is equal to 4. We'll go back to our original equation, plug in 4 where U was, and is 6 times 4 not 24? It is. Alright, now, I think what we're going to do is we're going to move on to generating expressions. Alright, and this will be a little lengthy, but well worth it. In word problems, they will give you stuff like, alright, let's generate an expression. They may say 4 more than A. And they want you to say, okay, well, how's that going to look? Alright, well, it could be A plus 4. 4 more means adding than A. 4 more plus 4 is going to be there than A. So both of these, we satisfy both conditions. 4 more than A. This is 4 more than A. Let's do another one. Let's double B. Alright. This could look two ways. It could look 2B 2 times B. Both of those satisfy double B. When we double, we already know that there's going to be 2 there. We're going to multiply by 2. Or, yeah, 2 dot B. That's also a symbol for multiplication. I forgot. Give you that. I want to give you all the information. 10 less than C. Okay. So we know we have 10. Less than indicates a minus sign. And then C. So we have to have a 10 less than minus sign and then C. So we could say C minus 10. So we have all our components. And this is all about reading, picking up the components. A half of D. A half of D. Okay, now this could, a half and D, those are the components. This is a little weird because it could look like this. It could be 1/2 D, or it could actually be D over 2 when you look at it. Remember, if we look at this as a whole number, what is it? It's 1 over 2 times D over 1. 1 times D is D over 2. So it translated to the same thing. But half of D, we have our half, and then we built our half in here to convert it to that, but it's still there. So a half of D, the half and the D, those are the components. And the word problems will always utilize this lingo or language. 8 more than E. 8 is one component, more than indicates adding, and E is another component, 8 more than E. Sounds like 8 plus E, not 8, 8 plus E. And this is indicated, if you don't see a symbol, that would indicate a positive symbol, but I think just to keep it tight, 8 more than E, I will leave it like that. The E is in there, the plus component, and the 8 component, all there. They could tell you 9 subtract F. 9 minus F, folks. They could say 4 lots of A. 4 lots of A. That would indicate 4 lots of A. So 1A, 2A, 3A. That looks like 4 lots of A to me. So the 4 component is there and the A component is there for A. We'll do 2. 14 less than I. Multiply I by 4. We'll do a couple of these. Divide K by 3. Double 1 and add 2. Okay, 14 less than I. I and 14 and less than is the minus component. So 14 less than I minus 14. Multiply I by 4. You could say 4I or I4 would satisfy it. Most people typically like the 4 and the variable, but you know, I would stick with this format because some professors and teachers might get a little funky with you. Divide K by 3. This could be K over 3, K slash 3, which is still like the same fractional form, or K divided by 3. Double I and add 2. 2I plus 2. Make sure I got all that on there. Okay. That's pretty cool. We knocked out a bunch of those. Okay. And again, if you need to pause, you need to stop, you need to slow down, I would suggest you write out everything like that was in blue. Like, let's see, double M, then add 5. You can't even see it. Double M, then add 5. Okay, there we go. We got it in there. Right? Double O, then subtract 3. Have P, then add 6. Subtract A from 10. Here we go. Okay, double M, then add 5. Double indicates a 2. M is what we're doubling, then add 5 plus 5. Double O, then subtract 3. Double O, 2O, then subtract 3, minus 3. Have P, then add 6. Okay, you could 1/2 P, or over here, you could P over 2. Sounds nasty, P over 2. And then add 6. So you could have either one of these and then plus 6. So it could be this, or it could be P over 2 plus 6. Subtract A from 10. Subtract A from 10. Okay. So this helps you look at the words and learn how to transform them into a mathematical format. So Rosie K in Lake Station, Indiana, I really hope this helped. Okay. So again, if this video helped you, I'd like you to like and subscribe it. This is the Math with Kieno channel. And if you have any questions, comments, concerns, or anything, I could be reached at lowercase KIENOTHOMAS at gmail.com. And you're in the subject box, just put math. So I know this is aviation related videos. In addition to that, I also do science subjects and aviation, all aviation topics. So I would like to thank you for watching and have a great night. Thank you.